Hello my dear students, this is Akash HD. Welcome to the ASD physics classes. Hope so you all are doing really great. So students, in this video we are going to solve the question from the chapter properties of fluids. Okay, so let's start the video. The question is, consider a solid sphere of radius r and density rho r. That means rho as a function of small r is equal to how much is given here? This one is given, rho equal to rho naught 1 minus small r square by capital R square, and the value of r is from where? R greater than 0, less than or equal to r. Okay, now the minimum density of liquid in which it will float is how much here? Okay, and you will think, what is small r? Small r is always, most of the time, variable. Okay, small r is always variable. We used to take from the center to the observation point. Okay, and here the key word is there, flotation. For flotation, what will happen that here? Very basic concept, the weight of the body should be equal to the buoyant force into the fluid. And here what is the fluid is there? The fluid is the liquid. Okay, so I will write here, see, very basic thing for flotation. Now then we'll see. For flotation, what I told you? I have told you this mg should be equal to what? Buoyant force here. Now if we talk about here mg will act in which direction? Let's take for example, this is one sphere, solid sphere. So what will happen that here? This mg will act in downward direction here. Okay, and if we talk about here the buoyant force on this body will act in a opposite direction of the weight. Okay, so what is this here? This is mg, and what is this here? This is the buoyant force. Okay, and this solid sphere is where? Inside the liquid. Now after that, what will happen that here? Let's see here. If we talk about here the mass of the body, here the main point is there to calculate the mass of the body, because this density is what? Variable. This density is the variable. Okay, so first let me write here. This is the mg. Buoyant force formula. Buoyant force formula means density of the liquid into volume of the body immersed, okay, into gravity g. Okay, now what will happen that here? Let's see here, very basic, this g and this g cancelled. Now we can write here, see, this mass m is equal to density of the liquid immersed volume. You can see the body is completely immersed into the liquid. That means immersed volume is equal to the volume of the body. And what is the volume of the body? You can see radius is r and this is the spherical. So we can write here 4 by 3 pi r cube. Is it? Now we will see here this mass. What is the mass formula? You know very well, the density equal to mass by volume. So what is mass? Mass means density into volume. Okay, but here you know very well this density is the variable. So what I will take here? I will take here the density into very small volume, rho into dv, and then I will do the integration, because here variables are involved. And what is dv? dv is the volume of means very small volume of the sphere inside, that I will show you here. Okay, and what this is coming here, you can see here rho L into 4 by 3 pi r cube. Now what we are going to do now? We are going to find out this very small volume. Okay, so let's take here, this is one solid sphere is there, and what is the radius of this sphere? The radius of this sphere is from center r. Okay, so this is the radius. Now to get very small volume dv, what I will take here? I will take here a very thin ring. No, very thin ring is there, and what is the radius? No, radius, no, inner radius, this one here. You can see inner radius. What is this inner radius? This is small r. Okay, and the thickness of this very small ring, I will take here dr. Very basic is there. Okay, this one, very small thin ring is there. Okay, very small thin ring is there. Okay, very small thin ring. How much thickness of the ring is there? dr. What is the inner radius? Small r is there. Okay, so if I talk about here, what is the volume of this ring? No, volume of this ring. So you know very well here, what is this inner? Now you can see here, now this inner hollow sphere is there. Now what is the area of the inner hollow sphere? You know very well here, 4 pi r square. What is this? 4 pi r square. Area of inner sphere. Actually, if you will think about the ring, it is just like a hollow sphere. Na? Like this is the hollow sphere. So this one, how much here area? 4 pi r square. Thickness how much here? dr here. So when you will multiply this 4 pi r square into dr, what you will get here? You will get here the very small volume. dV equal to 4 pi r square into dr. But if we talk about here this solid sphere is made up of very thin rings. So many thin rings are involved, just like an onion. If you talk about the onion is solid, but what is there inside? Very small rings are there. When so many rings will combine, then only complete onion will form. So here also, when so many small rings will be combining, starting from r equal to 0 to r equal to capital R. So when I will combine all these small rings, then I will get here the complete solid sphere. And this is which kind of sphere? This is the solid sphere is there. Okay, that means I can make like this. This is the solid sphere here, like this. Is it? Kindly see here. Now very easy, I have to just put the value of this dV and I have to just do the integration. Okay, so we'll go to the next page now. So here we know very well integration of rho into dV is equal to what is there? See, 4 by 3 pi r cube. Is it? 4 by 3 pi r cube into density of the liquid. Now let's put here the values. What is the rho? Rho is given here. You can see here the rho is given by what here? Rho naught. This thing is there. Na? This I will write there. Okay. So see, this rho is given here. Rho naught 1 minus small r square by capital R square. Na variable with small r, this density is keep on changing. Na? This density of the sphere is keep on changing, because when we are going from center to the surface, small r values keep on changing. Na? Variable. So this density is keep on changing. That's why very small volume. What is the very small volume? You know here 4 pi r square dr, and here we can write here, see, 4 by 3 pi r cube into rho L. Now what we'll see here, what are the things can be cancelled out. So you can see here this 4 pi and this 4 pi is cancelled. Okay, and what are the things are left? You can see r cube, and by 3 I will take this side. So this will become here what? 3 by r cube. Now, and here you can see this rho naught will come outside. Okay, so integration, and this will become here, see, 1 minus small r square by capital R square into r square dr is rho L. That is the density of the liquid here. Okay, so let's see now here 3 rho naught by r cube, and here just multiply r square inside. So what this will become here, see, r square minus 1 by r square into this will become here what? R to the power 4. Okay, r to the power 4, like this, and here I can write here dr is equal to rho L. Now limits. Now dr is there. Now we have to put here the limits. Limits where to where? As I told you very well, this solid sphere is made up of so many rings. We have to add all these rings. So here at this point, what is the value of the small r is 0, and when I am at the surface, what is the small r is here? Capital R is there. Okay, so small r equal to 0 to small r equal to capital R, I have to integrate it. R equal to 0 to capital R. Okay, now let's see here. This is the 3 rho naught by r cube, and see here, if I will see here this r square into dr. Na? So see, even if you write here, I will write here one more step. R equal to 0 to r, and this will become here r square into dr minus 1 by r square, and again we can see r equal to 0 to r, and this will become here what? R to the power 4 into dr, and that is rho L. Okay, after that we are just going to write here the next side step. Okay, next side steps will write here. So now what we can write here, see, here we can write, see, 3 rho naught by r cube, and here bracket. So see, r square into dr, that means the what will come here? It will become here r cube by 3. If you know somewhat basics now, because formula is what? I will write here the formula. Integration of r to the power n dr will be r to the power n plus 1 by n plus 1. Okay, this is the formula here. Because this is a definite integration, so no need to write here the plus c and all that. Okay, so r cube by 3. Okay, and here if I write here, what this will become now? See, minus 1 by r square, and here r to the power 4 dr, what this will become here? See, r to the power 5 by 5 here. Okay, and overall you can see 0 to r, this is also 0 to r, so I can just write here this is 0 and this is r, and equal to density of the liquid. Okay, so let's see now 3 rho naught by r cube. Is it? Now let's put here the limits. No? So only we have to put here the upper limit, because lower limit 0, all things will become 0. So when you will put here r, it will become here r cube by 3 minus. When you will put here r to the power 5 by r square, that means it will become here r cube by 5 if is equal to rho L. Now what will happen that here, see, 3 rho naught by r cube into r cube will come outside, so we can write here, see, 1 by 3 minus 1 by 5 is equal to rho L. Is it? Now what we can write here, see, what other things can be cancelled here? See, this r cube and this r cube is cancelled. So 3 rho naught here, and here LCM, this is 3 into 5, this will become here 5 minus 3 is equal to rho L. So what we can write now, see, 3 rho naught, and here this will become here what? 2 by 3 into 5 is equal to rho L. Is it? Now students, what other things can be cancelled out? Let's see here. This 3 and this 3 is cancelled, so we can write here density of the liquid is going to be 2 rho naught by 5. This is the density of the liquid. Then only this solid sphere will float. Solid sphere will float. So 2 rho naught by 5. 2 rho naught by is where? Here you can see 2 rho naught by 5. So students, I hope so. This question in which density is the variable and we have done the integration and all that is very, very clear to you. Keep studying, keep going.